All right, in our last session here this evening, I want to talk about the solar system. I call this worlds of creation because the planets and moons that the Lord created, they're beautiful, they are amazing, they're stunning and fascinating, and they declare God's glory. And they certainly don't declare a Big Bang or a solar system collapsing from a nebula and so on. And so what we're going to do here is I'm going to use some computer software to examine each of these worlds and just talk about it a little bit. I don't really have any notes here. I'm just kind of going to go through the solar system and be wowed with the amazing things that the Lord has created. And we live in a very blessed time. It's a crazy time, but it's a blessed time too, because we have been able to explore all the large worlds of our solar system. All of the planets have been visited by spacecraft. Even that little dwarf planet, Pluto, has been visited by spacecraft. And a lot of the moons and asteroids and comets, it's amazing. And we have these beautiful high-resolution images of these worlds. And what we can do with modern technology is we can take those pictures and mathematically deconvolve them such that we can then, I can make a model of them that's based on actual images and rotate it around. And so everything you're going to look at tonight is based on real images that were taken. So it's reconstructed in software, but it's based on actual photographs by spacecraft that have been there. I think that's amazing. I think that's awesome. I mean, if you think about it, for the first several thousand years, for the first 5,600 years of humanity's history, the planets were little spots in the sky, and we only knew them up to Saturn. We didn't know about Uranus or Neptune or anything like that. And then in 1610, Galileo points his telescope at and sees that Jupiter, wow, it's got a little size to it. It's got these 4 little moons that orbit around it. Amazing. So we're going to take a look at the solar system. This is the solar system, the way it would look right now. If you look there, you have the sun in the center there and the 4 inner planets. This is the inner solar system. And it was actually a creation scientist who discovered the nature of these orbits. They're actually ellipses. Prior to Kepler, they thought they were circles, but Kepler figured out they're actually ellipses, which is kind of a squashed circle. A circle is the set of all points in a plane equidistant from a given point, whereas an ellipse is based on 2 points. The sum of the distances to the perimeter is the same for those 2 points, and those 2 points are called foci. Each one is a focus. The sun is at one focus of the ellipse. And what that means is planets come a little closer to the sun sometimes, and then they're a little further away at other times. You can see that with Mercury there. Mercury is just one of the most elliptical of the orbits. You notice that sort of near the top, it's closer to the sun than when it's near the bottom. And that's correct. That's something that Kepler figured out. And he was using data from another Christian, Tycho Brahe, who had made very accurate measurements of the planets, especially Mars, as seen in Earth's sky from Earth. And so, Kepler was able to figure out that the planets orbit in ellipses with the sun at one focus. He was able to figure out the relationship between the period of a planet and its distance from the sun. And he was able to figure out the speed of a planet within its orbit, how it varies as the planet gets closer to the sun. He was able to discover the exact mathematical relationship there. Pretty amazing. And you might say, well, I don't know. I think I can see that those are ellipses. That's not so hard. But of course, Kepler didn't have a nice computer program like this, or any computer at all. He had a list of numbers of the positions of Mars in coordinates as seen from Earth. Now, if you think about that, he's trying to figure out the orbit of one planet while riding on another planet, which means you have to solve both problems simultaneously. You have to figure out the Earth's orbit and Mars's orbit at the same time to see where Mars would appear from Earth. I hope that gives you a little bit of respect for the guy. He was bright. He was clever. And he was the guy who, very devout Christian, and he said that doing astronomy is like thinking God's thoughts after him. And I think that's a great approach. That's what I think of science. It's thinking God's thoughts after him. So there you go, Kepler's laws. And then it was another creationist, Isaac Newton, who came along and figured out why the planets orbit that way. It has to do with gravity. The sun has gravity, and that causes the planets to fall in a circular fashion. If the planets didn't have any kind of sideways motion, they'd fall directly into the sun, but because they have some sideways motion, they sort of fall around the sun. That's what an orbit is. You're falling around something rather than toward it. It's a pretty neat way of doing these things. So there's the inner planets, Mercury, Venus, Earth, Mars. Now the outer planets are quite a bit further out. Let me zoom out here. So there you see Jupiter, Saturn, Uranus, Neptune, and poor little Pluto. He's still there, but he's no longer considered a planet. Very sad. But anyway, and you can see the outer planets are barely moving. We really have to speed up time quite a bit and make the inner planets really whip around there until you get Jupiter to orbit and Saturn. Saturn takes close to 30 years to make a complete orbit of the sun. So, and that's something, again, that you could find by using Kepler's laws of motion. His third law gives you the period in relation to the distance. So pretty amazing. Neptune, just a few years ago, made its first orbit since it was discovered back in the 1850s. So it's kind of neat to think about that. And Pluto still has it. Pluto was discovered in 1930, but its orbital period is 248 years. So it still hasn't made an orbit since its discovery. It's made a few since creation, but not since its discovery. So all the planets orbit in approximately the same plane. And so if we look at the solar system from edge on, you can actually see that. And I would call that a design feature because they're sort of organized. They're all orbiting in the same direction. And the fact that they're all on the same plane, that keeps things very organized. It prevents one planet from making a close pass to another one and so on. But my secular colleagues also have an explanation for this as well. They would say that the solar system collapsed from a nebula. And as the nebula collapsed, it would speed up like a skater when she pulls her arms in and she speeds up due to conservation of momentum. And it would tend to sort of pancake out. And so that kind of works. So I don't pick on them for that. But we have an explanation too, is my point. And sometimes in books you'll see the solar system from an edge-on perspective. And if you weren't aware of it and you thought that's an overhead view, you might think the orbits are really elliptical. They're not. They're only slightly elliptical. But yeah, they're pretty close to a circle. And that's a design feature too, because we don't want extreme temperature differences if the Earth were really super close to the sun sometimes and further away other times. So let's go back to the inner solar system. What I want to do now is just go to each of these planets. We'll start with the sun, actually, because the sun's rather important to the solar system. It's 99.98% the mass of the solar system. So the rest of the stuff's just sort of dust, right? So there's the sun. It looks kind of like that. It's very bright. Again, it produces more energy in a second than 1 billion major cities could use in a year, so that's pretty neat. It's got sunspots on it. And those are regions that are cooler than the rest of the sun, and therefore they don't glow as brightly. They actually are glowing, and if you could separate them from the sun, you'd see that. But by contrast, they appear dark because they're cooler. The magnetic fields of those sunspots inhibits the convection from the interior of the sun from getting to the surface, and so they just cool off. So that's what happens there. You might notice that sort of bubbling pattern that you see on the sun. That's supergranulation. Each one of those supergranules is about the size of the Earth. So it just gives you a feel for the amazing power of that thing. And the power of God, obviously, is spoken to existence. So I spent years studying the sun. That was the topic of my doctoral dissertation at the University of Colorado. But I'm sure you'll all want to read my dissertation later, so we'll skip that for now. I'm kidding, you don't want to read that. Probably less than 10 people have read it. Okay. So the first planet out, Mercury, we've sent at least a couple spacecraft past Mercury. There was the Mariner probe back in the 70s. And that's what Mercury looks like. It looks kind of like the moon. It's a very heavily cratered planet. There's almost no atmosphere on Mercury, and so anything that comes really close to it just, boom, hits the surface and forms a crater. Probably what Earth would look like if we didn't have that protective atmosphere that we have. And other features, oceans and plate tectonics and so on. So there's Mercury, just kind of like the moon. It's about a third the size of the Earth, and it's 3 times closer to the sun. It has the shortest year. It orbits in 88 days, but it's got a very slow rotation. It takes 58 days for it to turn once on its axis. So the day side of Mercury just gets baked because there's no relief from that sunlight. It's been in direct sunlight for weeks, and there's no atmosphere to carry away the heat. So the day side reaches temperatures of 800 degrees Fahrenheit. Pretty nasty. And then the night side, because it hasn't seen the sun in weeks, just radiates away that heat. Heat doesn't last millions of years, right? So that the night side of Mercury is like negative 200 degrees, very chilly. So it's a planet of extremes. And by the way, since the day side is 800 degrees, the night side is like negative 200, there would be a place kind of right about there just before sunrise where the temperature would be pretty comfortable. So if you ever crash land on Mercury, you want to aim right there, okay? And by the way, if you did crash land right there, put on your spacesuit. There's no air on Mercury, so you got to put on your spacesuit. You better start running west, because if you don't, the rotation will carry you into sunrise. But because Mercury rotates so slowly, you could actually outrun sunrise, as long as you kept running west. Now you know what to do if you crash land on Mercury. There you go. You heard it here. One of the interesting features of Mercury is it has a magnetic field, and that was something that was a bit of a shock to the secularists because if you were here last night, I talked about how magnetic fields naturally decay with time. We've been able to measure that for Earth's magnetic field. It appears to be an exponential decay. The data are consistent with that. That's what we'd expect based on electrical current, free decay of electrical current. And so the fact that Mercury still has a magnetic field, despite the fact it's 3 times smaller than Earth, is really good evidence that it's not billions of years old. It's a few thousand years old. And there's even evidence that the magnetic field has decayed between the visit from the Mariner spacecraft back in the 70s and then the more recent Messenger spacecraft. It seems to have decayed a little bit. So that's what we'd expect as creationists. Pretty neat. And oddly like the moon and perhaps like the Earth would look if we didn't have that protective atmosphere. So neat little world and evidence of recent creation. So the next planet out, Venus, has been called Earth's sister planet because it's about the same size as the Earth, just a little bit smaller. And but aside from that, that's where the differences end. Same size, well, and it's a rocky world like Earth. You could theoretically land on it. And the Russians actually landed several probes on Venus. They were really fascinated with this planet for some reason. In the old sci-fis, you'll see a lot of exotic life forms on Venus. I still remember in old Outer Limits where William Shatner landed on Venus. And anyway, he got to go up recently. Isn't that neat? It just shows you anybody can go as long as you have millions of dollars and are a celebrity. Okay. So there you go. And because Venus has that thick atmosphere, it's 100 times the pressure of Earth's atmosphere, so it'd crush you like a tin can. And it has that thick atmosphere that traps in the heat really effectively. And so it's thick, and so it has a greenhouse effect that makes the surface temperature even hotter than Mercury. Venus is about 900 degrees Fahrenheit at the surface. Day or night, doesn't matter, because that atmosphere distributes the heat, the wind distributes the heat. And so it's not a place you want to go on your next vacation. The atmosphere those clouds are made up of sulfuric acid type compounds. So there's just lots of wonderful ways to die on Venus. It is not a place you want to visit. And we now know what the surface looks like because the Magellan spacecraft went into orbit around Venus and it used radar. Radar can penetrate those clouds. And so we know the surface looks like that. Kind of interesting, that's a radar map of the surface features of Venus. The other thing you might notice is Venus rotates backwards. The other planets, at least Mercury, Earth, Mars, and so on, they rotate counterclockwise looking over the North Pole. Venus is just exactly the opposite. And the interesting thing is that really is contrary to what the secularists would expect, because if our solar system collapsed from a nebula, you would expect all the planets would be upright, they'd be rotating in the same plane and in the same direction, and really with about the same speed. Venus is just exactly the opposite. It rotates backwards and very slowly. Its day is longer than its year. So it's kind of interesting. So again, I sometimes wonder if God does those things just to confuse the secularists, because there isn't any secular explanation for it. It shows God's creativity. So the backwards rotating Venus, problematic from the secular point of view, perfectly consistent with biblical creation, however. And those clouds that would kill you if you were there, they make Venus very beautiful. It's one of the brightest objects in our sky. You got the sun, the moon, and then Venus, third brightest object. So next out, we have my very favorite planet, Earth. Earth has the most restaurants of any planet, and the most of anything else you can think of that's artificial. So all your friends live there, you live there, and so on. And it's a beautiful world, and what a privilege we live in a time where we have photographs of the Earth from space. It's really quite remarkable. And again, my friend Jeff Williams, NASA astronaut, who's spent more time on the International Space Station than just about anybody. And he often sits in that little bubble in the space station, takes pictures of the Earth. It's quite stunning, quite beautiful, beautiful world. Of course, it has liquid water on its surface. Now, the water molecule is actually pretty abundant in space. There's a lot of water vapor in space, and there's ice, but liquid water is rare because it requires a fairly narrow temperature range and a certain amount of pressure in order for water to be liquid. And of course, Earth has those conditions. It has water vapor and ice as well, but it's got 71% covered with water. So that's pretty neat. And of course, that's a life condition. We'd expect that. Isaiah 45:18, God formed the earth to be inhabited, the Bible says. And so it has all kinds of life features. It has that magnetic field, which deflects cosmic rays. And that would be, cosmic rays are bad for your DNA. They can mutate your DNA, give you things like cancer and so on. So a few of them make it through anyway, but the magnetic field protects us from that, although it's decaying, but not something you'll have to worry about in your lifetime, though. And then, of course, it's tilted. The Earth is tilted relative to its orbit around the sun, and that is what causes seasons. So when the northern hemisphere is tilted toward the sun, we get more direct sunlight. The sun's higher in the sky. You have more daylight hours, so you get more energy. It's not that you're closer to the sun. In fact, we're actually a little farther away from the sun in summer than we are in winter. You're closer to the sun in winter. But the angle is lower. The sun's lower in the sky in the winter, and you have fewer daylight hours. So seasons, and that's a design feature. Seasons make the Earth's habitable zone greater than it would be otherwise. If you made the Earth upright so that it had no seasons, then that would reduce the habitable zones. The poles would be colder, the equator would be hotter, and so on. So it's a design feature. All kinds of wonderful features on Earth that make it just right for life. Mountains, valleys, a lot of beauty on the Earth. It has a moon, which we call the moon. For most of history, this was the only moon we knew of. It was a wild thought that other planets could have moons. Nobody knew that until 1610. So there's what the moon looks like. We always see the same side of it, and you have those dark features. Those are maria, and it's from the Latin word meaning seas, because they used to think they were seas, but they're actually basalt. They're places where magma has filled in any previous craters there. So we think that God probably used a bit of process when he made the moon on day 4. And maybe some large objects hit it later, and that formed those large magma pockets that you see there. That's where we think the maria come from. Because they're almost all on the Earth-facing side of the moon. So there it goes. The moon goes through phases, and that just depends on where the sun is relative to our perspective of the moon. So the sun would be off to the right in this image, and you have that gibbous phase. People have the impression the moon doesn't rotate because we see the same side, but it does rotate. It just keeps the same face pointed at the Earth. So as it goes around the Earth, it also rotates. And that's why you have the same side. So we know what the other side looks like, and you see it doesn't have those large maria that the Earth-facing side does. There's the Earth in the background. Isn't that beautiful? I've always been a little bit envious of the 12 people who got to walk on the surface of the moon and look up and see Earth, that little blue gem up in the sky, knowing everyone that they've ever known or will know, it lives on that little blue gem. Quite stunning. Looks very fragile there, hanging in space, suspended on nothing, as the Bible says in Job 26:7. So there you go. The moon is a design feature in that it stirs up tides. It causes tides on the Earth, and that keeps the oceans from stagnating, cleans the shorelines and so on. So that's a design feature. And the moon has what we call remnant magnetism, where you have little bits of magnetic fields, and that indicates that the moon once had a global magnetic field, but in 6,000 years it's decayed away, because magnetic fields just don't last that long. We know that from measuring Earth's and apparently Mercury's as well. So pretty amazing system. The moon is the largest in proportion to the size of its planet, in terms of the planets in our solar system anyway. So there's the Earth. The Earth also has plate tectonics, which makes it unique. Other planets have tectonics, but as far as we know, only the Earth has a crust that's divided into plates that can move under certain circumstances, and we think that's what God used to start and end the flood. So there's some neat models by John Baumgartner and Humphreys that have worked on that. So here's Mars, the next planet out. Mars is about half the size of the Earth, but it actually has a lot more in common with Earth than, say, Venus, right? Because Venus is the same size, but in other respects is different. Mars has all kinds of features, has mountains. You see those 3 pimples there, and that big one right there? Those are volcanoes. This large one is Olympus Mons. That's the largest known volcano. It's 3 times taller than Mount Everest, and the base of it would cover Iowa. It's huge. It's a shield volcano, one of the ones that erupted rather gently and formed the magma, or the lava, I guess, formed a fairly gentle sloping volcano. On the other side, you see that large dark feature there. It's called Syrtis Major, and the light feature, so Syrtis Major right there, you can see that in a small telescope. I can't tell you how many times I've looked at Mars in a telescope, and you can see that dark feature there. And below it, you have this valley right here called Hellas. It often fills in with fog and looks kind of bright, and people mistake it for the southern polar ice cap, but the polar ice cap's further down. So, and there's the northern polar ice cap. So Mars has ice caps like the Earth does. And they grow in winter and they shrink in summer, just like Earth's. But instead of being made of water ice, they're primarily frozen carbon dioxide with a little bit of water ice. So there you go. Another feature on Mars, if we rotate it around here a little bit, there's that large scratch mark you see there. That is Valles Marineris. That's an enormous canyon, about the length of the United States. Huge, dwarfs the Earth's Grand Canyon. And we think that's a tectonic fissure where the surface cracked apart, not a water canyon. Although there is evidence that Mars had water on its surface at one point. We find dried up riverbeds and deltas, and they tend to be near the volcanic regions. And so we think what happens there is when the volcanoes erupt, because Mars doesn't have liquid water on its surface today, as far as we know, not in any abundance. But, in fact, today the atmospheric pressure is insufficient to keep water in a liquid state. Water would boil immediately, go directly from solid to gas, skips the liquid state. But when a volcano erupts, it ejects water vapor, among other things, which condenses, and it temporarily increases the atmospheric pressure enough you can have liquid water for a little while. So we think that the water's temporary whenever a volcano erupts. We haven't seen a volcano erupt on Mars, so they're either extinct or possibly dormant, but they might happen. We might get to see one in the future, and that'd be pretty neat. So there's Mars. Mars has 2 moons. Actually, before I get to that, the other thing I wanted to point out is the rotation rate of Mars. Mars has a 24-hour and 36-minute rotation, so it's similar to the Earth. Tilted about the same amount of the Earth, so seasons would be about the same. But because the day length is 36 minutes longer, if we ever have a base on Mars, you could sleep in an extra half an hour every day and never catch up with you. I think that'd be really neat. So there you go. Mars has 2 moons. They're tiny. The outermost is called Deimos. Let's go to Deimos first. And it's wild and it surprises people because it looks kind of like a potato. How about that? People tend to assume that moons are round. Large moons are round. Smaller ones can have kind of a random shape because there's insufficient gravity to pull them into a sphere. It's only about 10 miles, a little less than 10 miles across. That's the size of Deimos. So it's very small. Look at that. So walking around that moon, that would be a nice little hike. You could do that in a day. And then the inner one is Phobos. So there's little Phobos. Phobos is a little bigger than Deimos. And there it is. It's in eclipse right now. It's right behind Mars. It comes out of eclipse. There you see it. Pretty amazing. And because it's so small, it doesn't have much gravity. Gravity is determined by mass. The view would be spectacular. Can you imagine looking up and seeing Mars? Because it orbits really close to Mars. I think that'd be a spectacular view. And the cool thing about Phobos, too, is the gravity's so weak, you can actually pick up a rock and throw it into orbit. You could watch it go over the horizon. In fact, you could play catch with yourself. You could wait for it and catch it, throw it the other way. It's interesting to think of these situations that they can't really happen on Earth. So there you go. So Mars and its 2 moons, Phobos and Deimos. The names mean fear and terror, because Mars is supposed to be the god of war, the Roman god of war, and what accompanies war but fear and terror. So there you go. But it's not designed for life. It doesn't have it has a thin atmosphere of carbon dioxide, and so you can't breathe on Mars. It doesn't have the global magnetic field that the Earth has, so you'd be subject to cosmic radiation. I think that's going to be an issue if we ever send people to Mars. I don't know how they're going to beat that one, but maybe they'll think of something I haven't thought of. In any case, it's not designed for life like the Earth is, but it's an interesting world, and I'm glad the Lord made it. It does have what's called remnant magnetism. We talked about that with the moon, little bits of magnetic field all over, which indicates it used to have a global magnetic field, but it's decayed all the way down since its creation 6,000 years ago. So remnant magnetism, even that doesn't last billions of years. So we've seen even Mars has evidence of not being anywhere near billions of years old. The Mars system. So those 4 planets we've looked at so far, Mercury, Venus, Earth, and Mars, they're called terrestrial, meaning Earth-like, because they all are solid. You could theoretically land on them. We have landed probes on, not Mercury, but Venus and Mars. You could walk on them in principle. The outer planets, no, they're different. The outer planets are gas. Jupiter is a gas giant. It's made up of gas, held together by its own gravity. Yes, even gas has a little bit of gravity. You have enough of it, it'll form a sphere, or it'll stay a sphere once you make it a sphere. So there you go. Big ball of gas probably becomes liquid at some point, but there's no surface on Jupiter to land on. You can't land on Jupiter. There's nothing solid there. And those stripes that you see on are called belts and zones. The belts are dark, the zones are light, and they're just clouds. Clouds that get stretched out into complete loops around Jupiter. kind of like jet streams on the Earth. The Earth has those jet streams, right? Jupiter has more of them because it's bigger. This planet is 10 Earths across. And so it's pretty massive. It's the largest planet in our solar system, but we've now found larger planets in others. Something I mentioned last night is Jupiter has at least two very compelling indicators that it's not billions of years old. One is its internal heat. It gives off more heat than it receives, and that can't last billions of years. And it's got that incredibly powerful magnetic field, far stronger than the Earth's, and that can't last billions of years either. Both of those indicate a recent creation for Jupiter. The other thing you notice, of course, is the Great Red Spot, which astronomers call the Great Red Spot because we're not very creative, but there it is. You could drop 2 Earths right in that thing. That's how big it is. It has been shrinking a little bit. This image is from probably the either the 80s or the 90s, so it was 2 Earths across then. It's now about 1.5 Earths. If you look at pictures from the 70s, it was like 3 Earths across, so it is shrinking. But the reason, that's basically a big hurricane. It's a big hurricane. Hurricanes on Earth are powered by the ocean heat. When a hurricane moves across the ocean temperature drops by 10 degrees afterwards. So it's powered by the ocean. It moves over the land. It gets cut off from its power source and kind of peters out. With Jupiter, no land. And so the hurricane's been going for a very long time. The red spot's been there for at least 300 years since we've had telescopes powerful enough to be able to detect it. And maybe since creation, for all we know. So, beautiful world. Fun to look at through a small telescope. Sometimes you'll get other little storms that will develop on it, little black spots, and also the shadows of the moons. That's fun to watch. Just a couple months ago, I was out looking at Jupiter with a telescope, picked a random time, and sure enough, the shadow of little Io popped in there on Jupiter. It was just fun to see. So that's what it looks like. Jupiter does have rings. You can see them faintly there, like Saturn, but they're very, very thin, and so you can't really see Jupiter's rings from the Earth. But the Voyager, one of the Voyagers, when it went past Jupiter, maybe it was one of the Pioneers, when it got past Jupiter and looked back toward the rings to get the glint from the sun, and you can actually see the rings of Saturn, or the rings of Jupiter there. So that's the shadow of the moon Io. Jupiter has 4 large moons that were discovered in 1610, and it has a lot of smaller moons that were discovered later. In fact, Jupiter has 70 moons. 70. But 4 big ones. So let's take a look at the big ones. The inner of the big 4 is Io, or Io. And I love this moon. Nothing looks like it. It looks like kind of like a pizza. It's just really odd. Or maybe an orange that you forgot you left in the refrigerator. And nothing looks like it. It's so strange. And that's because of volcanoes. This is the most volcanically active world in the solar system. Volcanoes are constantly going off, and they've completely resurfaced the moon since creation. Okay, so you're looking at the results of volcanic outflow. And in fact, when Voyager 2 flew past Io in the early 1980s, it detected 9 volcanoes going off simultaneously. So it's interesting little moon. About the same size as the Earth's moon, but very colorful, and it really makes me feel like we got ripped off on our moon because ours is so gray. This was just so beautiful and interesting. You'll notice it does like our moon. It keeps the same face pointed at its planet at all times. All large moons do that. Some of the smaller ones do too, but not all of them. So that's an energetically favorable position. It's very stable. So I think God created it that way for stability, but it would come to that position eventually anyway. So there you go. So there's Io, and Jupiter would look spectacular from Io. But you'd still be in that magnetic field, so that might cause some problems. So there it is, casting its own shadow on Jupiter. That would be fun to look at, wouldn't it? So Io, the innermost of the big 4. Next one out is Europa. And Europa is interesting because it has these large scratch marks on the surface, like a big cosmic cat came and just swiped it like that. And we think those are outflow sites where geysers of water vapor are spewing out of Europa, which indicates that it has internal heat. And when you have something like that that has internal heat like that, that's a pretty good indication it can't be billions of years old. Because as small as this moon is, it's a little smaller than Earth's moon, it shouldn't be able to retain heat for billions of years. And so that's a problem in the secular view. I've read some papers where they tried to propose solutions to that, but none of them really successful because there's nothing that could produce new heat. On Earth, the secularists would say, well, Earth has internal heat because radioactive decay produces that, which it does. But these outer worlds don't have the heavier elements, so they don't have a lot of radioactivity. So internal heat is an indication they're nowhere near billions of years old. Next out, we have Ganymede. Ganymede is the largest moon in the solar system. Kind of fitting that it orbits the largest planet. Makes it easy to remember. So there's Ganymede. I love Ganymede. Very beautiful. Kind of got that tritone color, the dark brown, the lighter brown, and the white ejecta from the more recent craters. Stunning. Ganymede's actually bigger than the planet Mercury, the first thing we looked at, right? But since it orbits a planet rather than the sun directly, it's a moon. But if you could separate it from Jupiter, it would be a planet, no doubt. So Ganymede, the largest moon. And then Callisto, the second largest of the Jupiter system. So there's little Callisto. That's the outermost of the big four. If you have a small telescope, you can always see those moons. They'll look like little points, but they're very bright. A small telescope, you look at Jupiter, you can almost always see the four moons, unless one of them is directly in front of or behind Jupiter or eclipsed in shadow. But otherwise, you can see them. And they're really pretty. And you can even watch them orbit. If you stay up late enough, you can watch them move. You can actually watch them orbit Jupiter, which is pretty spectacular, really. So that's the Jupiter system. You might notice here, too, there's Jupiter has aurora. I don't know if you can see that. See the glow there on the top? Northern Lights. That's because it's got such a strong magnetic field, because it's not billions of years old. And so when the solar particles from the sun hit that, charged particles, they disrupt it, and that causes those beautiful colors like we have around Earth as well. Now, the inner moons of Jupiter, Io, Europa, Ganymede, and Callisto, and then there are four that are small and interior to that. They all orbit in the same plane and in the same direction. Can you see that there? They're all going the way they're supposed to, counterclockwise from the top, the same way Jupiter orbits, the same way the other planets orbit, except for Venus, which is exactly backwards. And so that's a design feature, because there's not a lot of space available there. And so they really kind of have to be in the same plane and in the same direction to avoid collisions, where one would come close to another, or even just one of them gravitationally ejecting another one. That could happen too. The outer moons, not so organized. There's the outer moons of Jupiter. And if I speed up time, you can see the inner moons all orbit. They're all organized and orbiting in the same direction. The outer moons, they kind of do what they want. Some of them orbit in the same direction as Jupiter. A lot of them orbit backwards. Looks pretty messy. Now, in fact, each of those is a perfectly distinct ellipse. It's just that they're all different directions. And they're not even in the same plane. If I rotate the system, the inner ones are edge-on, but the outer ones, you can see it's just a mess. And again, that's a common feature that we see in the universe, because there's plenty of space available out there. And so the chances of collision are pretty close to zero. And so even though it looks crowded because we've made the lines kind of thick, but it's actually, there's actually a lot of space available there. So that's the Jupiter system. And then next out we have everybody's favorite, other than Earth, Saturn. Because Saturn has that gorgeous ring system. The rings of Saturn are trillions of tiny little moonlets. We set it to today. Trillions of tiny little moonlets that orbit around Saturn's equator. And they extend hundreds of thousands of miles into space, but they're only like a mile or two thick. And so it's very fortunate that the Lord tilted that planet, which it shouldn't be. If it collapsed from a nebula, conservation of angular momentum should cause all the planets to be upright. They should have no tilt. Saturn's tilted quite a bit, and that's a good thing, because if it weren't, you wouldn't know that it had rings, because they are very thin. And so that's interesting. Now even here you can see the shadow of them, because it's still tilted relative to the sun. But if it were not tilted relative to the sun or the Earth, you would not know it had rings until we finally got a spacecraft out there. So I'm delighted that the Lord tilted that planet for our enjoyment. And so there's actually a famous picture of Saturn in a crescent phase like that. And I don't think people realize the significance of that. It's sort of a proof that we've been there, because the only way you can see Saturn in a crescent phase, or anything in a crescent phase, is to get further away from the sun than the object is. You can't see Saturn in a crescent phase from the Earth. You have to go there. And so it's pretty wonderful. Of course, we can simulate that now with computers. We talked about, yesterday I mentioned Saturn has a magnetic field that deflects cosmic rays, but it's also an indication that it's not anywhere near billions of years old, because magnetic fields do decay with time. And Saturn's magnetic field really ought to be gone if it were billions of years old. And yet it's still there. So number of moons, I'm not going to do all of them, because Saturn has actually 72 moons. So we're just going to do some of the highlights. I do want to talk about Enceladus, because Enceladus is kind of like Europa in that it has these large streaks on its surface, and we know these are geysers. With Europa, we're not sure, but we know these are geysers of water because we've actually seen them erupting. And that indicates that this little moon, Enceladus, still has a great deal of internal heat, and it's a small moon. It's much smaller than our moon. And so the fact that it still has internal energy, despite the fact that it's 9.5 times farther away from the sun than Earth is, that's an indication it can't be anywhere near billions of years old. The heat would have been gone by now, by any estimate. And secularists say, well, maybe some kind of tidal flexing, but they've given up on that because the tidal flexing is insufficient for Enceladus to generate that heat. So it's mysterious in the secular worldview. A lot of things like that. They're like, wow, we don't understand that. And I'm thinking, well, I do. Biblical creation is the answer. It orbits in the plane of the rings, so you actually wouldn't see the rings if you were on Enceladus. So that'd be kind of depressing. Let's do another moon or two. Titan, second largest moon in the solar system, orbiting the second largest planet. Makes that convenient. So there's Titan. Nothing looks like Titan. It is orange. It is an orange featureless sphere, and that's because it has an incredibly thick atmosphere of hydrocarbons, like smog. Basically, it's a smoggy moon, and no other moon has a thick atmosphere like that. That is unique to Titan. Really interesting. And you can see that in a small telescope. You'll always see in a small telescope, you'll see Saturn, beautiful rings, and you'll always see an orange star next to it. That's Titan. And really neat. We've sent spacecraft past Titan. We've actually had an orbiter around Saturn, and it took nice images of Titan, but also using radar could penetrate the surface, so we can do like we did with Venus. And the surface, there's the surface of Titan. And you can see the atmosphere is quite thick when you remove all that smog. So that's why they used to think that Titan was the largest moon when it was first discovered. But that's because the thick atmosphere makes it look a little bigger than it really is, kind of puffs it out like a cat when they get upset. So there you go. And it has actually lakes of liquid methane, which was astonishing because they were expecting ethane. And there's a difference. Methane is destroyed by ultraviolet light. And of course, Titan's constantly receiving ultraviolet light from the sun, and it's been doing so for 6,000 years, and some of it has converted to ethane. But if it were billions of years old, all the methane should be gone by now. And so that is actually a problem in the secular view, but again, it's a feature for biblical creation. We would expect the amount of methane that is in the atmosphere of this little moon, or fairly big moon, actually. So another moon out, I want to do this one. This one's called Iapetus, and I really like this one because when it was discovered, on the right side of Saturn, it was easy to spot, but when it was on the left side, nobody could see it for a long time. And that's because one side of Iapetus is as bright as snow, and the other side's dark like charcoal. And because it's tidally locked, when it's on the right side of Saturn, you see the snowy side. When it's on the left side of Saturn, you see the dark side, right? So how about that? It's got a light side and a dark side, kind of like the Force or an Oreo cookie. And we think there's a reason for that. We think that as it orbits, it collects material from another moon out there, and that piles up on the leading hemisphere. So there's what it looks like with Saturn in the background. Wouldn't that be neat? And Iapetus is the closest moon to Saturn that's not in the plane of the rings, and so that's where I would want to set up a base, right? So you get a nice big view of Jupiter, of Saturn, but it's tilted so you can still see the rings there. The other thing that's interesting about Iapetus is it has a mountain range right along the equator. You can actually see it there. It's spectacular, and it's exactly on the equator. It's kind of amazing, and it's not quite round. It's like God, after He made it, just went and just kind of pushed it a little bit, and the mountains popped up. I say that facetiously, but I don't have any other explanation for how that would work. So that's the Saturn system, some of its more impressive moons. Like Jupiter, Saturn's inner moons all orbit in the same plane, and that keeps them fairly organized all the way out to Hyperion, and all orbit in the same direction, the same as Saturn rotates. That's called prograde. But then if you go further out, the outer moons, again, they're like Jupiter's. The outer ones, a lot of them orbit backwards in a retrograde orbit. And I'll speed up time here. And again, it looks pretty messy, but that's again, a design feature. There's not a lot of space near Saturn, so they have to be organized. They have to orbit in the same plane, in the same direction to avoid getting ejected. But the outer moons can kind of do what they want. The outer moons are very small, too, so essentially boulders in space. And again, they're not in the same plane. The inner moons are, but the outer ones are not. So there you go. A beautiful system. Now, interestingly, in the 1980s, the planets happened to be aligned such that they formed a giant arc, Jupiter, Saturn, Uranus, Neptune, and that allowed human beings to send one spacecraft past all those planets, which I think is a wonderful act of divine providence, because that doesn't happen very often. And it happened right at the time where technology had developed to where we could send a spacecraft out. And it saved us a lot of money. It allowed us to do something that we probably couldn't have done any other way, at least not until recently. And so in the 1980s, we sent Voyager 1 and Voyager 2. Voyager 1 flew past Jupiter and Saturn, and they wanted to get a good look at Titan. So it went past Titan, and that kind of ejected it out of the plane of the solar system. Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune. It was able to get all four. And so let's take a look at Uranus. It flew past Uranus in the year 1986. Now, Uranus is interesting because it's tilted on its side. I mentioned that last night. And again, there's no secular explanation for that, because it's not like it's a solid rocky world where something could hit it and turn it that way. It's just on its side for whatever reason. A lot of methane and ammonia in the atmosphere. The methane gives it the blue color, relay scattering from that. And it has 5 large moons, although none of them are really big, and then a lot of smaller ones. We'll just do one of the moons for time's sake. Miranda is probably the most interesting, because Miranda looks like it experienced some kind of catastrophe, like it's been broken apart and reassembled. And you can even see that reversed check mark there in the northern hemisphere. So we only know what the north pole of these world, or the northern hemisphere of each of these moons, because when Voyager flew past, Uranus had its northern hemisphere tilted toward the sun, depending on how you define that. And so only the northern hemisphere of the moons were illuminated. So we don't know what the other side looks like. I think we need a return mission because I want to know what the other side looks like. So there you go. Uranus has a magnetic field that is inexplicable in the secular view. Remember, the secularists were expecting to find no magnetic field on Uranus because they think it's billions of years old. Dr. Russ Humphreys predicted the magnetic field of Uranus in the year 1984. I've read the paper. And then in 1986, Voyager 2 flew past and measured the magnetic field, and it matched Dr. Humphreys' prediction. Pretty cool. Because you see, he started with the assumption that it's 6,000 years old. And based on 6,000 years, it should decay to this amount, and that's exactly what we find. And likewise for Neptune. So if you want to do good science, you better start with what the Bible says, if you want to get the right answer. You really do. The Bible's correct when it touches on astronomy, as when it touches on anything. So then in 1989, Voyager 2 continued and flew past the planet Neptune. And I love Neptune. It's beautiful. You can see Uranus and Neptune in a small telescope. They're not visible to the unaided eye, but you can see them. I love the color of Neptune. It's just this beautiful blue color, really quite stunning. And we were surprised to find this wonderful dark spot there. We thought only Jupiter had one of those until Neptune, and then Neptune has a great dark spot, essentially a giant cyclone that spins around there. And unlike Jupiter's red spot, this one comes and goes. Sometimes it disappears. Sometimes a different one appears in the northern hemisphere. We know that from the Hubble telescope, which can do almost as good as Voyager without actually going there. So pretty amazing. Neptune has both internal heat, like Jupiter, so it's giving off 2.6 times as much energy as it receives from the sun, and it has a magnetic field comparable to that of Uranus, which is consistent with its biblical age of about 6,000 years. That's what we'd expect given that amount of decay. Now, the inner moons of Neptune are pretty well behaved. They all sort of orbit in the same direction that Neptune rotates, so they're well behaved, but then, and then the same plane, but then Triton is just exactly backwards. And so there's Triton, and it's not even in the same plane. See, you can see it's tilted relative to the other ones. And that's interesting, because normally large moons don't do that. All other large moons orbit prograde. Triton's the only large moon that orbits retrograde. So let's go to Triton. It was really astonishing to the secularists because it's it's the largest of Neptune's moons, but it's not that big. And it's significantly smaller than our moon. And yet it has geologic activity on it, in particular geysers, of nitrogen geysers. You see those little black spots on Triton there? Let me zoom in a little bit. This was a wonderful discovery by Voyager 2. And what those are, they're geysers that carry soot up into a very thin atmosphere. Triton has a thin atmosphere, and the prevailing winds carry it and deposit it. That's why you have these horizontal streaks. That's soot that's being deposited by the wind. Isn't that fascinating? And that indicates that it has internal heat. You have to have internal heat to have geysers. That's what drives them. And internal heat cannot last billions of years. So that's yet another. We find all of these. I mean, it's just amazing. You'd think the secularists would say, well, yeah, there's no doubt from the evidence the solar system's a few thousand years old. It can't be billions. But see, if they admitted that, they'd have to give up their secular version of the the nebular collapse theory. They'd have to give up evolution and all that, and they don't want to do that. So it really doesn't have to do with science. It has to do with worldviews. In the northern section, you have these interesting features here. I don't even know what to make of that, but it sure is fascinating. The Lord's built a lot of beauty and interesting and strangeness into his solar system. Neptune does have rings, but they're very thin. They were discovered when Voyager 2 flew past it, and it was able to detect very thin rings on this world. 4 times the size of the Earth, about the same size as Uranus. So there you go. That's the Neptune system. And when I was a kid, Pluto was a planet. So we got to do Pluto, okay? And now it was not visited by Voyager 2 because it was not part of that great arc that you can still see it there. It was way off, so there was no way to get Voyager 2 past Pluto. But fortunately, the New Horizons mission, which was launched in 2006, is a spacecraft about the size of a grand piano, and we kept it as small as we could so it doesn't have as much mass, so you can push it as fast as you can and get it really out there quick. And it took 9 years to get to Pluto, which it reached in 2015. And what a delightful surprise Pluto was. From a secular standpoint, it was very surprising. I should point out that, one hemisphere of it is kind of low resolution. That's because the spacecraft was far away when it was taking pictures of that side of Pluto. And then as it got closer, the other hemisphere is rotating around. Pluto takes about 6 days to rotate once. And so the spacecraft, it was just a flyby. It flew past Pluto, not enough fuel to slow it down and go into orbit. And that would have made the mission much more expensive. And so by divine providence, we got the really interesting side when it got really close to Pluto. And you have this enormous heart-shaped feature, Tombaugh Regio, really pretty, really amazing. Now, this was totally contrary to the secular expectations because Pluto is only 2/3 the size of Earth's moon. It's small, and that contributed to its demotion from planethood. It got Plutoed. So, so being that small and being 39 times farther from the sun than Earth is, there shouldn't be any heat at all on Pluto, especially if it's billions of years old, because any energy that it started with would have dissipated into space billions of years ago. And so the expectation was, since there's a lot of other objects out orbiting at the same distance as Pluto, they should have slammed into the surface. Pluto should be completely covered with craters. It shouldn't have any kind of geological activity because that requires heat. That requires internal heat to power that motion. And to their surprise, yes, there were a few craters, but not a lot. It's not totally covered with craters. In fact, this area right here, Sputnik Planitia, there's not a single crater in it. Not one, which indicates that any craters that were there previously it's been resurfaced. And it looks actually like convection cells, much like the supergranulation on the sun. And I think that's probably what it is. But that requires internal heat, at least in the past, in the recent past, in order to drive that convection. You have mountains, you have valleys. That requires tectonic activity, geological activity, not plate tectonics, but nonetheless geological activity. You can see some of these mountains down here. These are about as tall as the Rocky Mountains in Colorado. But instead of being made of rock, they're made of ice, water ice. At that distance, ice is as hard as rock because that's how cold it is out there. So you can have mountains made of ice, something to think about, covered with a thin layer of methane ice. Pluto has a real thin atmosphere sometimes. The theory is because Pluto has an elliptical orbit, it comes close to the sun. It reached its closest point to the sun in 1989. And then 100 and some years later, it'll reach its farthest point from the sun. We think that when Pluto's close to the sun, there's enough energy to make some of the methane gas, and then we think that atmosphere freezes out at some point. So part of its orbit, it has no atmosphere, part it does, but it's always thin. If it's there at all, it's very, very thin. So there's Pluto. Pretty amazing. Pluto has 5 moons, but only one of them is big, and boy, is it big compared to Pluto. It's about half the size of Pluto. It's called Charon. And there it is. And again, Charon, it's got a few craters, but it's also got valleys and canyons and all these things that shouldn't be there if it was billions of years old. It's almost as like it was created a few thousand years ago. How about that? Because you need internal heat to drive that kind of geology. Got a dark North Pole, which we've never seen before. That's kind of interesting. And so really kind of an interesting little world there. And I'm going to do the named features because the astronomers that discovered these things have named the features. And I like this one because they've named them after sci-fi characters for the first time. So you got Spock Crater and Kirk Crater and Ripley crater and Vader crater, Skywalker crater, Mordor. So Lord of the Rings was not left out. So I think that's kind of neat. So astronomers have a sense of humor too. I don't know if those names will stick, but I kind of hope they do. So there you go. So pretty amazing. So that's the large of Pluto's moons, and then it's got 4 smaller ones. They're really small. So there you go. That's the Pluto system. Pretty amazing, and I'm delighted we get to see that because I wasn't sure we'd get to when I was a kid. We'd seen the big ones, and I thought, but where's Pluto? So nope, we finally got there. Pretty neat. And so that's just kind of an overview of the big worlds of our solar system. There's a lot more to our solar system. There are asteroids, and there are comets, and there are things like that we could go into, and they're interesting too. But then we'd be here for millions of years, so we don't want to do that. But I do want to remind you, though, that of all these amazing worlds that the Lord created, it was on this special planet where God walked, where he became a human being, took on human flesh, remained God, but still about human as well, and died for our sins. That's pretty awesome. And so again, as that astronaut said, it's one thing that man walked on the moon. It's even more amazing that God walked on the earth. That's pretty special. So we live on a very beautiful and very special world. And I hope you've enjoyed that presentation. I hope you've enjoyed this conference. And please avail yourself of the resources. We've probably already started packing up, but we might have a few left out there if you want to get those. Do check us out on the web at biblicalscienceinstitute.com. I will stick around, and if you want to ask me questions, I think we'll just do it that way, if that works for you. Okay? Thank you very much. God bless.
Yes, we really, really thank you. I mean, it is a fascinating subject, and it's great to be here live and to be able to catch it. But if you know people, you can always tell them to check it out online. And but better than that, you can get a permanent record of a lot of these things in his resources. I do think, yeah, they put a lot of the tables out, but they think they have everything out, but just in reduced tables. So your last chance, and great deals you can get. Again, a lot of this stuff is not so much to convince you, because you're probably here most likely because you already believe, but you're getting equipped to be able to answer some of the questions that people have. So we're blessed to thank you for all the staff that helped put all this together, and thank you for the Jason's team, everything that coordinated together so well, and thank you for coming. So let's close in prayer. Father, we're grateful for this opportunity just to see the heavens declare your glory, and Lord, your weight, your substance, that you are real, that you're not just a figment of imagination, but Lord, as we observe the universe and we see, certainly it declares your glory. And we pray, Father, that for some that have a predisposition against you and your creation, and that things just evolved, I pray, Father, that, Lord, you'd be merciful and use those of your people that are convinced about you to shine that light, that hope. I pray, Father, that they'd be willing to see that hope and be able to answer or ask the questions, for the hope. Why is there hope? Why do you have hope? And I pray, Father, that, Lord, you give us those good answers, good defense for the hope that's in us. Thank you. We appreciate this time. In Jesus' precious name, we pray. Amen. Jason will be around. Dr. Lisle will be around. I wanted to call him Lisle, but that's because that's how you spell his name, so in case you're getting confused on that. But he'll be around, and the resources will be around shortly, and then they're going to be packing up. God bless you. Thanks for coming.